70% of our universe is made up of something so weird and so strange, it continues to baffle the world's brightest minds.
We are absolutely still lacking great ideas.
It is crying out for some new breakthrough, new thinking.
Perhaps the greatest remaining mystery in our universe. What is dark energy?
Dark energy is basically our name for that thing that we don't understand.
It's not the color dark, it's just an expression of our ignorance as to what is this stuff.
Genius could come up with a new theory. Yeah, it is quite possible. I'm kind of hoping it's me.
So this is clearly a huge deal in physics and raises many, many questions. The obvious one to start with is, why do we think dark energy exists? Now, ever since the Big Bang, our universe has been expanding, with space itself stretching, moving galaxies further apart. Now, physicists used to think that the energy that was made in the Big Bang to power that expansion would eventually start to run out and the expansion would start to slow down. Then, a Nobel Prize-winning discovery turned all of that on its head. Saul Perlmutter and his team measured the way the universe was expanding by comparing the brightness of supernova. This is when a star runs out of fuel at the end of its life.
They brighten as a firework and fade away, and they reach the same brightness. And you can then use that as an indicator of how far away it is by just looking to see how bright it appears to you. Just like when you watch a car recede into the distance, you can tell how far away it is by how faint the taillights look. If you can use the brightness of the supernova to tell you how far away it is, that's really telling you how long ago the explosion occurred, because you know how long it takes for light to travel that great distance.
And what they discovered definitely shook the physics world.
Suddenly, he was saying that we lived in a universe that was accelerating. I remember it just being incredible. I mean, all the astronomers walking around, scratching their heads, saying, this can't be right, surely it can't be right.
Now, exciting as this finding was, like many things in science, it raised a lot more questions than answers.
Once you know that the universe is actually speeding up, then you're faced with the question of, well, what could make it speed up?
This mysterious thing that was causing this newly spotted phenomena that no one could explain was immediately called dark energy. Now, it's great to have a name for this, but it doesn't exactly explain what is driving this accelerated expansion. So what is this energy? Now, just like with dark matter, which makes up 25% of the universe and is also currently unexplained, this weird type of energy seems to defy our laws of physics and has properties that our current models just cannot explain.
So you can think of it as you get more space, you actually get more dark energy, which is like getting something for nothing, which is clearly ridiculous. The way we think about it is that it's either some new stuff in the universe, some particle, or even just a new field that you put into the universe to explain the properties of the universe.
So what is it that's changing the way our universe evolves? Well, scientists differ in their thoughts of what it could be, from a liquid or a brand new particle like dark matter, or even an unknown force. Now, scientists at Berkeley in California are looking for something that they call chameleon particles. This is a whole new type of particle that's thought to create a force, which when it interacts with other particles, changes those particles' mass. By putting atoms in a vacuum, they're hoping to expose these chameleons.
The experiment works by first collecting a cloud of cesium atoms on top of the spheres, and the atoms are free to fall, subject only to the Earth's gravity and the potential chameleon force. We will either discover the particle or rule it out once and for all.
So far, they haven't found any evidence for these chameleon particles and their elusive force, but it is an idea that continues to be explored. So whatever this energy is, we now know that it makes up a whopping 70% of our universe. So how can we figure out what it is? Now, the obvious place to start is by looking at how the universe formed and has evolved with incredibly powerful telescopes.
One of the things that I do is try to simulate the entire universe and tie what we think about the physics of the evolving universe to what we actually see with surveys like DESI.
DESI, the Dark Energy Spectroscopic Instrument, is one of these incredibly powerful telescopes observing the distant universe. Now, the further away galaxies are, the younger they appear to us. That's because light takes time to travel to us. It can take even 1 billion years to reach us here on Earth. Thanks to this, we can look at the average distance between galaxies at different cosmic times and look how it's changed due to the expansion of the universe, and therefore figure out what is the role of dark energy. And what we need to do that is more detail, and we get more detail from more data. Now, there's a lot of projects and telescopes that are mapping the universe in this way, but one that we're all very excited for is the launch of the space telescope Euclid in 2022. It's the most powerful telescope ever created, even dwarfing the iconic Hubble Space Telescope. So it could be just what we need to solve this problem.
These are going to be the biggest images that come down from in orbit. You have an image effectively of 625 megapixels. So that's roughly 300 HD television screens full of data, and that comes down every 10 minutes. This imager takes roughly the same amount of data that Hubble has taken and will take in its entire lifetime in one day.
The hope with Euclid is that it will be able to give us the detail that we so desperately need to be able to solve this problem.
We have like lots of theories and hundreds of models that could still fit our data. When Euclid comes, lots of these can be thrown away, and it could narrow down the possibilities of what this dark energy is.
Euclid will give us a coherent data set that we can test all these theories against.
So dark energy remains the biggest mystery in physics, but with all these great scientific minds across the world and all the projects focused so desperately on figuring out what this is, it might not be long before we finally find this huge missing piece of the puzzle.
We need teams like Euclid. That's the only way you can get the data that you need. But to understand that data, to give it some interpretation, to give it an idea, could come from one person. That could be the next Einstein.